find the integral of 2 minus sine x squared dx. Now, it is probably very tempting to go straight in and put, say, u equals 2 minus sine x. Then you'd do your stuff with a, differentiate that and so on, get some expression for dx, and you'd end up with the integral of u cubed, sorry, the integral of u squared, which would be u cubed over 3, something like that. Don't do that. Yes, it might give you something that technically is the integral, but it's not what you want. You always want as lower order as possible. So what we actually want to be doing here is we're going to expand the bracket. Whenever you've got powers of trigonometric functions, so sine squared, cos cubed, sine cubed, what we're going to do, we're going to use identities to reduce the order of those, and then we're going to differentiate, so integrate like that. So what I'm going to do first of all is a bit of expansion on that bracket. So equals the integral of, well, perfect square, so 2 times 2 is 4. 2 times minus sine x is minus 2 sine x, and there's going to be 2 of those, so minus 4 sine x. So both of these terms would be fine. The third term is the problem, which would be minus sine x times minus sine x. It's plus sine squared x dx. So what I'm saying is we need to try and reduce this to a double angle thing. So the one I always remember is that cos 2x equals 2 cos squared x minus 1. So you might be thinking, what's that got to do with sine squared x? And yes, I know it, there is one in your formula sheet that just involves sine squared, and I probably should be using that, but this is just the one I always remember. So I know that sine squared x plus cos squared x equals 1. So cos squared x equals 1 minus sine squared x. So if I write this one again, cos 2x must equal 2 1 minus sine squared x minus 1. So that would be cos 2x equals 2 minus 1 is 1 minus 2 sine squared x. So that would mean cos 2x minus 1 equals minus 2 sine squared x. I'm just going to swap those around. So 2 sine squared x equals 1 minus cos 2x, which would mean that sine squared x equals, if I just divide this by 2, so it's 1/2 minus 1/2 cos 2x. So I am going to substitute this into where I saw my sine squared x in there, and I'm going to rewrite the integral. So if I call this the integral, so I can finally, I've got a transform integral, which should be okay. So now the integral equals, so the 4 and the minus 4 sine x were fine anyway, 4 minus 4 sine x plus 1/2 minus 1/2 cos 2x. Cos 2x. So I should really make that look better, dx. So yeah, 4 plus 1/2, 4 1/2, 9 over 2, so equals integral of 9 over 2 minus 4 sine x minus 1/2 cos 2x with respect to x. So we're going okay, so I think I might just try and do these. So 9 over 2 is going to integrate to 9 over 2 x. Minus 4 sine x, well, minus cos differentiates to sine, so cos must differentiate to minus sine, so 4 cos must differentiate to minus 4 sine, so this is going to be plus 4 cos x, and then you've got to integrate this minus a half cos 2x. So no, I won't take a shortcut. So let's say if we get this and put it down here, so we say let u equal 2x, du by dx equals 2, dx equals a half du. So now you might say the integral equals, or I equals, minus a half, the minus a half that was already there, times the other half, times the integral of cos u du. So minus a half times a half is minus a quarter. This is going to go to sine u, so equals minus a quarter sine u. And since I haven't got room, I'm going to write 2x plus c. So then I can just write this up here. So my final answer, 9 over 2x plus 4 cos x minus a quarter sine 2x plus c. That is my final answer. All of this was just to find the integral of minus a half cos 2x with respect to x.